Welcome back. In this video, we're going to start fleshing out the catalog services infrastructure layer. So let's get started by adding a new class library here. We're going to make sure we put it into the right service folder, catalog service, and this will be catalog infrastructure. All right. Now, in a typical infrastructure library, what I'm going to do is have areas, folders that represent different areas of concern, just like we do in our domain layer here. So first thing I'm going to do is create a folder called products to match the same folder structure I have in the domain layer. And in the domain layer, if you recall, we have our domain object. We have for the repository, we have an interface, and then we have a DTO object for representing when we're going to be passing a product back across the boundary between us and the client. So that's what we got in the domain layer, and what we're going to be adding now, I'm going to create 3 folders because these 3 folders are typically always going to be present in the infrastructure layer folders. Commands, queries, and repositories. So I had mentioned in the earlier presentations that I would be implementing a logical CQRS. So if you're not familiar with CQRS, basically what it says is we're going to distinguish between calls from the client that are queries, in other words, that do not change the state of the application, but are more about just retrieving data. So those are queries. And commands. Commands are actually issued from the caller and are intended to change state. So we can differentiate between the two. Now, in a traditional CQRS, you would actually have separate databases as well. One that is strictly meant for altering and keeping track of state, and the other one that is meant for answering queries. And you would keep the two in sync, and various methodologies exist to do so. So if a command is issued to change the state of, say, in our case here, a product, in the product database where we keep track of commands, a couple different ways we could do that. We could have a relational database. We could have what's called an event sourcing database. And whatever change we end up making there, we need to make sure that the read database that is used for answering queries maintains synchronization as well, and there are different methodologies for doing that. I would prefer in this application and a lot of the applications that I write to actually keep it in the same database, and that's why it's called a logical CQRS, because we're going to differentiate between commands and queries, but only at a logical level, not at a physical level, and we're not going to have physically separate databases for the commands and the queries. So with that in mind, first thing we can do is actually implement our repository class for the product. So we're going to have product repository. So this is the actual concrete implementation of our iRepository. Oops. Trying to talk and think at the same time. Not always works out. Product repository here is what we're going to implement. We need to add a reference. And sorry, we're also going to inherit though from our base repository class. Oops. Oh yes, and we need to clarify what repository we're implementing here with our type T. So in this case, it's for product. All right, there we go. And then we're actually going to need to, as you recall, pass in, there are certain dependency injections that we pass into the base repository here. So we need those passed in at this level as well, and it happens to be the iUnit of work in the user session. So we're going to say iUnit of work. Jeez. And iUser session, and those are both going to get passed into our base class. Oh, did I bring in Martin services again? Not our unit of work, my bad. There we go. And so, in the last video, we spent a decent amount of time fleshing out our base repository class, right? So let's go back and visit that again. Our base repository class, anytime we inherit from it, gives us automatically out of the box, without doing any extra work in the repository that we're implementing, the get by ID, insert, update, and delete, which are, a lot of the common things we're going to do with most of the repositories. So if we just wanted to support the ability to create products, update products, delete products, retrieve a product by its ID, we are done. And that's why, it took a little bit of effort to flesh out our base class for the repository. But the great news is now that we've fleshed that out, we get those methods that we just looked at for free every time whenever we're implementing a repository, which can save us a lot of typing, a lot of duplicate code, and makes the repositories pretty clean. So for the moment, there's going to be other methods that we're going to want to implement eventually around the product, ways that we're going to want to potentially pull products out of the database, like maybe by its product code and things like that. But for now, let's just leave it as is. So our repository is done. Basically, we just have to declare the class, inherit from the base repository class, pass in a couple dependency injections, and we are done. All right, so now let's talk about commands and queries. So again, this is how the client is, the client's actually going to be calling our API, but our API, as we'll see when we go to implement that, is basically going to use, we talked about it a little bit in the last video, a library called Mediator, where Mediator, that library allows us to basically say, all right, whenever we have an object or a command or a query of this type, I want this particular class to handle it. And that's how we're going to allow the API layer to basically say, hey, this is the incoming request, take care of any field level validation, things like that. But then through Mediator, say, here's the request. I'm not sure who's supposed to handle it, but Mediator, here's the request, and figure out who's supposed to handle it. So what we're going to be building here in our commands and queries are those handlers. We're also going to build the actual object that's going to represent, the incoming query itself. So on the query side, one of the things that we want to implement is the get by ID essentially. So what we can do in our queries folder here. So we're going to say get product by ID handler. So this is going to be the class that's actually going to handle the request to get a product by its ID. And as I mentioned, we're going to take advantage of the Mediator library again. And so what we can do is implement an interface called iRequestHandler. And we're going to take in some sort of, whenever we have some sort of request, and in this case it's going to be get product by ID, and we're going to create that in a second. So whenever we get a request of that type, what are we going to return? Get place by ID response is what we're going to end up returning, and we're going to build that out in a second. Now, what I like to do for both the queries and the commands is we need these, we've got our signature for the handler, but we need to actually implement our get product by ID, essentially request and response. So I like to keep them all in the same class. I think it makes it very easy to understand and find the code, so that when you're looking at a request handler, you can immediately see the request and the response objects. So we can go ahead and implement right here, get product by ID. Sorry, I'm going to put request on the end of that. And it's going to also implement a Mediator interface called iRequest, where we need to say, okay, what is it going to return? And it's going to be get product I'm sorry, I just realized I have a typo here. Not a place, we're getting a product. So the other class we have to implement here is get product by ID response. And so here we are going to actually return, and here we can inherit. You can make some choices here. So we already have our product DTO object, which represents a product that we're going to be returning. And so what I often do is just, okay, we're going to inherit from that, and that's what we're going to end up returning. So our response is actually going to be a product DTO. And one last thing here is, so on the request, what we're going to be receiving is an ID. Now, as we've talked about a little bit before, whenever we have something coming in from the client and we're going to be using model mapping, ASP.NET Core model mapping, we need to make sure that the gets and the sets are both public. So this is not one of our business objects, where we want to make sure that in the business objects we're always using private setters, making sure that people are using methods to change state on the object. Here, this is going to use model mapping, and it just represents the request coming in. So it's not a business object, it's just a request object coming in. So the fact that we don't have a private setter is perfectly fine, and in fact we need it for the model binding. That's what ASP.NET is going to do for us automatically. So the last thing we need to do is actually implement the interface, which is, again, from Mediator here. The interface is basically saying, okay, when you get this type of request, get product by ID, we need to return a get product by ID response. So you can see all this sort of fits together. So we have a request that implements iRequest, which is from Mediator, saying, okay, when that request is sent or issued, what is it going to return? Well, it's going to return a get product by ID response. And our get product by ID response is going to be an instance of a product DTO. And then we have our handler, which says, okay, whenever I get one of these, I'm going to return one of these. So if we did something different here, like product DTO, it's going to start complaining because it's going to say, for the request by ID, product by ID request, we're expecting to return a product by ID response, and so that handler won't make any sense. Hence, this needs to match here. We want the handler response to match whatever the request response would be. And then we're going to come in here and we're going to actually implement this. So one of the things that we need to pass into our handler here is our repository. So we're going to have a product repository, which is how we're actually going to call the database to get the requested product. And so we're going to say product is going to get the response from our request ID. So we're going to have our product, and the last thing we need to do then is actually take that and we need to map it, right? So we have what we get out of the repository is a business object, in this case the product. We need to convert that to a product DTO / get product by ID response. So this is where we're going to use a really great handy tool, a library that it gets used in a lot of C# projects called AutoMapper. And AutoMapper, you can read the details about it, but essentially the way it works is it just looks to say you have to tell AutoMapper at runtime, okay, when I'm going to allow the mapping of this object to this object, and when it goes to map it, it's essentially looking for field names that match. So if the two objects, the one that you're mapping from and the one that you're mapping to, has several fields, and wherever there's a field name match, like in the product world, we're going to have, if we look at our DTO here real quick, we're going to have a fields ID, code, name, and description. And on our product object, we have code, name, description. ID comes from aggregate root / entity base class. Therefore, what AutoMapper does is says, okay, anytime you want me to map from this guy to this guy, I'm just going to look for matching field names, and I'm going to take whatever's in the name field and move it to the name field, copy it to the name field of the other object. So that's what we wanted to do, is essentially map from our business object that we got from the database to our response object. And so we're basically going to have the way that AutoMapper works. Whoops. And let's add AutoMapper now. So obviously we could be doing a lot of that ourselves, writing a mapping class that takes as input whatever it is that we have, in this case a business object that represents a product, and converts it to whatever we need, in this case a get product by ID response. But Mapper just makes that a lot easier for us, so we're saving a lot of code by doing this. So we're also going to have an IMapper and IMapper is going to come from AutoMapper. Go using Mapper, and we are done. So what we haven't done yet is actually wired up AutoMapper. Like I said, one of the things you have to do with AutoMapper is you have to tell it what are the valid mappings that you want to support. So you want to be able to support, in this case, going from a product to a get product by ID response, and we're gonna have to wire that up somewhere, and we're gonna see that in a moment here. But for now, we're done with our request, right? So again, this is a get product by ID handler, takes in a get product by ID request. And what is the request? Well, it's going to have the ID of the product that is being requested. And in the handler, we're going to go into the repository, get that particular product, and then map it to our response. Now, on the command side, we want to implement, for now, we'll do two methods, which is create a product. So we're going to have create a product handler. And then one of the other things that we're going to have is the update. So let's start with create product handler. And just like in the request, we need some sort of request object and response object. So I'm going to just copy these guys. We'll start renaming some stuff. This is going to be create product request and create product response. And so in the response object, we are simply going to return the ID of whatever got created. So when we go to create this product, once it gets saved, it's going to end up with an ID. And that's what we're going to end up returning, is the ID of the object that got created. So in our request, we need to take in various properties, though, that are going to be necessary to actually create the object. So what we can do is steal these guys. So we're going to say that the code, the name, and the description are required when creating the product. So that's what our request object's going to look like. What we're expecting from the client is the code, the name, and the description, 3 string fields. So that's what we're going to take in as the request. And then as the response, we're going to return the ID of whatever it is that we ended up creating. So here we need to iRequest handler again. And we're going to be returning, or we're going to be handling, sorry, create product request. And so then we'll actually use IntelliSense to give us the boilerplate. So what do we need to do here? Well, first thing we need to do is actually create a product. So we have a product, and the way we create a product is through its constructor. So we're going to pass in the request.code, request.name, request.description. And then we're also going to need the, sorry, one sec. All right, then we're going to need the product repository again. We're also going to need our unit of work, because our unit of work is how we tell the system to actually go off and commit our changes. So we're going to need the iUnit of work to do that. So we're going to say product repository insert, and again we get that right out of our product repository by simply inheriting from the repository base class. So we're going to insert our product. Need to await that with an async. Oh, my IntelliSense keeps bringing in the Martin version. We don't want the Martin version. We want ours. There we go. And we need to commit. And then we need to return a response object. So let's look at this code again real quick here. So we're receiving in a request that has 3 string properties on it. We're going to take that request and its properties, and we're going to create a new product. We're going to insert it into the database via the product repository. We're going to commit our changes via the unit of work, and then we are going to simply return a response object where it has one property, the ID of what the product that we actually created, letting the front end know the ID of the object. Now, we might want to add some business logic here, right? Around, let's make sure that the code is unique. Let's make sure that the name is unique. A couple things like that. So we're definitely going to come back to that. I want to save that for a separate video. It'll be soon to follow, where we want to be able to add business rules. I think the most important thing for the discussion now, though, is where do we put those business rules? So in a non-domain driven design scenario, you would see these validation rules potentially sitting right here in the handler. So the handler might say something like, it might use the repository to say, Mr. Repository, is there anybody who already has this name for the product? And if so, we'll throw an exception. Now, in domain-driven design, what we're really looking for, though, is keeping the business rules where they belong in the business object itself. We want non-anemic business objects. So we're going to look at how we end up pulling that off, but the main summary point for now is we really want to enrich our business objects to be able to handle all the things related to the business object, including validation rules and things like that. So we'll see how that gets implemented. But for now, we've essentially finished our method for creating a product. Now, what we want to do is create one for update, and I'm going to cheat. I'm going to simply copy our class here, change the name here to update, and we are going to come in and update. Update. And update. Now, there's an important difference that we're going to end up with in our update, which is to say we're going to, sorry, I just got to change these 2 guys on the method signature real quick. Get rid of our red squiggly there. What we want to do differently is this would be an existing product. So incoming, in addition to the fields, is going to be the ID of the product that we're looking to update. Our response object is totally fine. I typically just still return in response the ID of the object that got updated. And the difference is going to be that when we come in here, we're not actually going to be creating a new product. We're going to be saying product is going to get await product repository, get by ID, the actual product that we're looking to update. Then we can say product.update. That's one of our methods that we have on our product object. And we're going to, again, use our request fields to update it. And again, we're going to come back and we're going to implement some business logic in here. If there's any rules that we want to follow that the object must adhere to when an update's occurring, we're going to take care of that. And then we're going to do update instead of insert here. And that's our update method. It's pretty straightforward, where we basically just get the existing object. We call its update method, and then we, on the product repository, instead of calling insert, we call update, and we end up committing it. And then again, we return a response object that is simply going to be the ID of the object that we updated, which is the product.id. So we've implemented here in reasonably quick fashion here an ability to create a product, update a product, get a product by its ID, all using the product repository as the way to interact with our database along the way. So I had mentioned we have to wire up AutoMapper here. So my typical approach for that is right in the root of our infrastructure folder, right in the root of products here, we're going to create another class here where I'm going to call it products AutoMapper. So it's going to match the name of the folder, and then it's going to end in AutoMapper. And then what we need to do in here is create something that inherits from profile, which is coming out of AutoMapper, you can see here. And so during the constructor, we're going to use the handy methods we get from our base class profile from AutoMapper to basically say what we want to map, what we want to support from a mapping perspective. So what we want to be able to support is going from we had a situation where we wanted to go from a product, the business object, to get product by ID response. All right. Now, had we forgotten to do this, you can see if we come back to our queries here real quick, just to remind you what we have here, we're using AutoMapper here to say, I want to map my product. This is what I'm giving it as input to what I want as output is the get product by ID response. There was no squiggly, no error message or anything like that to warn us if we had forgotten this guy here. What it would result in is a runtime error. So when the application was running and it finally got to that point to do the mapping, if the mapping had not been defined, AutoMapper would throw an exception saying, hey, you haven't defined this mapping, it's not a valid mapping, and you'd get an exception. So that's the way that you end up finding out that you've forgotten to do a mapping, is you'll get a runtime error when you go to test it. So we've got our products AutoMapper there, which is good. And that's actually going to be it for this video, where we've covered the basics of the way that we're going to create our infrastructure layers in the various microservices. What we're going to do in the next video is we're going to add our actual API layer then. So once we have our API layer done in the next video, we're going to have the ability to actually start running some tests soon afterwards, where we can use things like Postman to actually hit our endpoint and verify that we've wired all this up correctly, that we can create products, we can update products, we can get products by their ID. So that's where we're going to go in the next couple of videos. Time for a shameless plug for my personal LLC, Keystone Code. I've been doing software development for 20 plus years now, and I've been lucky enough that I've played a lot of the different roles that go into software development, from back-end developer, front-end developer, full-stack developer, team lead, head of engineering, chief technology officer, business analyst, and architect. So if your agency or company has any needs across those different areas, whether it be a need from just understanding what those roles are, or have a need to fill one of those roles, either from a training perspective, a mentor perspective, or an actual hands-on perspective, feel free to reach out. So I can be reached at my email address, dmichael@keystonecode.com, or on the website at keystonecode.com. Thanks.